For this recording, we're going to be discussing the straight line, right? More specifically, finding the equation to a straight line. Perhaps let me just highlight that here. Let me highlight that. So it's finding the equation, but equation for what exactly? This straight line. So we are still on the topic of analytical geometry, right? The analytical geometry. So analytical geometry, it's like the geometrical shapes that form part of our discussion. Mostly they are quads, right? You also find triangles as well, and these quads and triangles are constructed or made up of straight lines. So at some point in your in analytical geometry, there will be a point where we have to find the equation for these straight lines. So in this recording, we're going to be doing exactly that, finding the equation to a straight line. So we know that a straight line has the following form of an equation. It's of this form: y equal to mx plus c. Mx plus c, where the m represents what? The gradient. It represents the gradient or the slope, right? The gradient or the slope. And then the c represents what? The y-intercept. The y-intercept, right? So this is one way of finding a equation to a straight line. It's by using this general form. You start off by finding the gradient and then finding your y-intercept, right? Or you can use this other formula, y minus y1 equal to mx open bracket x minus x1. Okay, again, you need the gradient and 1 point. In fact, for both forms of equations, you're gonna need the gradient, and 2, you're gonna need 1 point on the graph. 1 point on the graph or the line. Okay, so I'm gonna draw a line, a straight line, and then we're gonna try to calculate the equation for that line, né? Using these two equations, using both equations. So we're gonna call the y equal to mx plus c equation number 1, and then the second one we're just gonna call it equation number 2. So let's say maybe you have a straight line like this. Perhaps it starts here, and then it stretches, say, all the way up to this point. Yeah, I'm trying to create a random line here. A random line. Okay. Now, this line of yours has the following coordinates. Let's say maybe you are given this coordinate here, and you are told it's 6, 7, 8. So it's 8 and 1, 2, 3, 4. 8 and 4. And then you also have minus 5. You also have minus 5 and negative 3 as y. So let's call this point A and point B. Then, as you can see, this is a straight line. So you are required to find the equation. For line AB. Okay, for line AB. So let's use the first equation, the first generic equation, number 1. We're gonna use y equal to mx plus c to calculate the equation for line AB. What did I say? I said we need the gradient, right? We need the gradient. We need to calculate M. We also need the value for C, which is the y-intercept. It's unfortunate for this equation, for this line AB, we are not provided with the y-intercept. So we're just gonna use a point on the plot. Just on any point. Anyway, we are given A, we are also given what? B. So the first thing we're gonna have to calculate is the gradient. So gradient for line AB is equal to YB minus YA over XB minus XA equal to, what is YB? YB, it's this coordinate minus 3 minus YA. YA is 4, it's positive 4, so it's just gonna be a 4. XB, it's minus 5 minus, then we also have XA, which is 8. It's XA, or it's that point, 8. So the answer should be minus 3 minus 4, that's minus 7 over minus 5 minus 8, it's negative 13. It's negative 13, so the answer should be a positive 7 over 13. But let's just check. Let's check. Minus 3 minus 4, minus 3 minus 4, and a minus 5 minus 8. Yes, it's a 17 over 13. Then we're gonna substitute our gradient to this equation. So t y equal to the gradient, which is 7 over 13x plus c. Now to get the point C, we can either use B or we can use A, and just substitute it into this equation and find out find the point, the value of C. So let's use A. So we're gonna take A and substitute it into this equation. So we're gonna say A, 8 and 4. Then it's gonna be, where there's y, we're gonna substitute the 4. Then it's gonna be 7 over 13, open bracket, x, it's 8. 8 plus c. Then it's 4 equal to 30, 7 over 13 times 8. 17 over 13, 13 times 8. It's equal to 56 over 13. Yeah, 13 plus c. Then transpose this value so that we can get the value for c. So it's going to be 4 minus 56 over 13. So c is equal to 4 minus 56 over 13. So c, it's going to be minus 4 over 13. Therefore, y is going to be equal to 7 over 13 x minus 4 over 13. So this is the equation for line AC. Now, let's use the second equation. Let's use equation number 2 to find the equation for line AB. Do not forget, we calculated the gradient to be 7 over 3. So I'm recalculating the equation for straight line AB. But instead of using mx plus c, I'm going to use the second equation. The y equal to, it's y minus y1 equal to m, open bracket, x minus x1. So we're going to use this one to find the equation for AB. So we just calculated the equation to be y equal to 7 over 13 minus oh, I did calculate it here, so it's minus 4, so it's 7 over 13x minus 4 over 13, 4 over 13. So we calculated the equation to be using y equal to mx plus c. Now let's use the second equation to calculate the straight line AB. Alright, so for this one, again, you need the gradient. You need a gradient and 1 point. And 1 point. Guess what? We did calculate the gradient. The gradient, we found it to be 7 over 13. So I now have the gradient. So instead of using A this time, I'm going to use B. But it really doesn't matter. It doesn't matter. So I'm just trying to show you that you can just pick any point and use it in your calculations. So instead of using A like we did on the previous calculation, let's use B instead. So I'm going to substitute B as minus 5 minus 3. So y1, I'm going to sub in 3. So it's going to be y minus negative 3 equal to, what's the gradient? 7 over 13. X minus, what is x? It's minus 5. Minus 5, close bracket. So it's going to be y plus 3, 7 over 1, 3. And then it's going to be x plus 5. Now let's remove the bracket. It's going to be a 7 over 1, 3. X, 7 over 13 times 5, that's plus 7 over 13 times 5, that's 35 over 1, 3. Then y is equal to 7 over 1, 3. X plus 35 minus 1, over 1, 3. 1, 3 minus 3. Are you ready? Are you ready? Are you ready? The answer should look exactly like that. The equation that we are trying to calculate should look exactly like the one above. So 35 over 13 over 1, 3 minus 3. I'm getting a minus 4 over 1, 3. If you are getting something different, something is wrong with your calculator or your hands. Okay, so the equations, they look the same. Okay, so just to sum it up, getting the equation or finding the equation for a straight line, it's either you use the y equal to mx plus c equation, get the gradient and also 1 point, substitute it into the equation, and then you get your c. Now you have your equation. Or you can use the second equation, right? You also need a gradient and 1 point, right? Then you substitute and then you make y the subject of the formula, and then you get you have your equation for a straight line. I hope you got value out of this discussion. If you have any questions, let's talk in the comment section. So if you enjoyed, leave a like. I'll see you on the next one. Peace.